All right. Um, cool. So I'm gonna start off. Let me make this a little bigger. I'm gonna start off with uh, talking about some of the I guess additional features that your JavaScript runtime environment has. So we haven't really talked about JavaScript runtime environments, but you have JavaScript, which is the core language, which has all of the the keywords and kind of does the like all the basic stuff, just like Python has a core language. And then JavaScript also, needs to run somewhere. Um, and it, originally runs in the browser, and there are different browsers have different, slightly different implementations of a runtime environment. And in that runtime environment, in part because it runs in a browser, so it needs to have access to browser things like we saw, like alert windows or opening a tab or you know stuff like that. And so that functionality is actually provided as an API. So that stuff like alert and opening a tab, that's not like JavaScript as such. That's something that's available to JavaScript as an interface or an API that you can use when you're running JavaScript. So that distinction, hasn't really been too important till now, but it can be important. So when we run JavaScript, locally, if I want to run, let's say console log, and I run it with Node. So Node is a runtime environment. It's it's newer. So JavaScript was originally developed to run in the browser. Node was developed, after JavaScript had been around for a while, to run on servers, basically to be like a backend for the backend that also used JavaScript. But you can, we run this on our computer, but because this is meant to run basically on a backend server, there's no browser. So the API that the kind of surrounding additional functionality that the Node runtime environment provides can be a little bit different than what the browser provides. So just to let you know, it's not, you don't need to like really worry about that too much, but you will see that. So we saw that actually when we were doing the Deaf Grandma challenge, where Python had a built-in input, so it could grab input from the terminal, but Node didn't have that, so we had to use a third-party module. And if you were running that on the browser, you could get input from like a text box or from the HTML or something like that. Okay. All right. So with that, we'll talk a little bit about the kind of structure of how JavaScript runs. So first off, I'm gonna console log hi, and then I'm gonna use something called set timeout. So set timeout is something that that will run in the browser or in the Node API, but it's not really a part of JavaScript as such. But we can use it here. And set timeout takes two things. Takes a function that it will run, and the second parameter is a time in milliseconds. So I can do 3,000 milliseconds. That's 3 seconds. And what set timeout will do is it will basically run this function after 3,000 milliseconds. That's not entirely precise, but that's roughly what happens. So in here, I can run something else. So I'll console.log. And then finally, I'm going to console log. Okay, so the question is, when I run this file, what am I going to see? What's the output going to be? Any guesses?
Will it be inner log? Then after 3 milliseconds, it will display by. Is that? Oh, I don't know.
Okay, so it'll say hi, and then after 3 seconds, it'll do inner log, and then it'll do by. Okay. Any other guesses? You guys are not very adventurous today. Maybe because you know that I'm going to trick you, because I am going to trick you. So let's look at a similar example in Python. So in Python, I'm going to import sleep. So it doesn't really have a set timeout exactly, but so from time import sleep, and I'll do print hi sleep 3, so it takes seconds instead of milliseconds. And then I'll print, maybe I should write a, yeah, let me do this a little differently here. I'm going to define a function. And I'll call sleeper, and then print by. All right, so I'm going to run this Python. So Python, so hi, and then 3 seconds, inner log, and then by. So is that what you guys were expecting? Something like this? Hi. I mean, that makes sense, right? I print hi, I call sleeper, it waits 3 seconds, logs this, and then it calls by. Now, JavaScript, surprise, surprise, doesn't quite work that way. So if I run the JavaScript file, it goes hi by immediately, and then after 3 seconds does inner log. So it goes hi, and then I guess somehow skips this or something, and then by, and then after 3 seconds does this. So any ideas? Is this a bug in JavaScript? Any ideas as to why it's happening?
Is that because it runs? I mean, all programs run top down, but so that'll go top down, and then the counter will keep going. So it'll say, so there's no pause. Like what I'm assuming happens is in Python, it goes one function to the next. So it's going to go top down. It's going to hit sleeper, and then it's going to go 1, 2, 3, and then run. But JavaScript, it's going to go top down, and when the counter starts, it doesn't stop running. It just keeps going, and then when that timer hits, it flips on.
Okay, cool. So yeah, so it will, so both JavaScript and Python will execute from top down. Basically, there's JavaScript, there's a minor exception, but it'll go top down. So it starts here at the top and then executes this. It executes this, but then it also is able to keep going, right? Whereas the Python just stops. It executes this, waits to finish, executes this, waits to finish, executes this, and then finishes. So what's actually happening here? So Python, you can do threading in Python. It's kind of a, has anyone ever heard of or used threads before?
Like with CPUs.
Yeah.
it's just like multiple processes can occur simultaneously.
Yeah. So you can other languages, Python has threading, Java has threading. Other languages will have threads, and it's basically a way you can spin off little sub processes. So you can kind of run things at the same time. So we're not going to talk about threading. You don't need to worry about it. But so that's one way of trying to do multiple things at the same time. So you don't have to wait. So for example, you could, run each of these on a different thread, and they could all kind of execute at the same time. JavaScript is single threaded, so JavaScript doesn't have threads. But this is kind of acting like something that's threaded, because if it's on a single thread, that means that everything's on the call stack. Basically, there's one call stack, right? So you put this on the call stack. When it's done executing, it gets popped off, and then this gets put on the call stack, and when it's done executing, it gets popped off, and then this, and so on. But that's not really what's happening. So JavaScript, the JavaScript runtime environment adds it adds the ability to kind of pause and resume execution, and we'll take a look at how that works right here. So here is kind of a representation of how JavaScript is going to be executed. So here's the call stack. So we're familiar with the call stack, right? We've seen it, especially when we were doing recursion. So your program executes. When it hits a function, it puts that function on the call stack. And then if that function calls another function, it adds another thing to the call stack. And then once that inner function returns, that gets popped off, the value gets returned, and then the initial function can return and gets removed from the call stack, and then the program can keep going. So that's kind of the line by line execution using the call stack. JavaScript has this the JavaScript runtime environment, which when we're running this on our local machines, it's Node. When we're running it in the browser, it's a web API, but it's the same kind of thing. What that does is it will actually take some of the pressure off of the normal JavaScript execution. So instead of JavaScript having to execute everything, it can kind of hand things off and basically clear out the call stack, so that the program can keep running as though it were almost as though it were multi-threaded. So set timeout is one of those functions. So when I call set timeout, it gets put on the call stack here. And JavaScript, because this is something which comes from elsewhere, it comes from this Node API or web API, it actually it hands off the execution over here. So when this let's say we have a console log right here. So we have a console log just like this program. Console log set timeout console log. So console log, this gets put in the call stack, it gets executed, right? So it's popped off. Then the set timeout comes on. And then the set timeout gets handed off over here to be dealt with. So the call stack is now cleared. So then the second console log can get popped on and then executed and removed. Meanwhile, what's happening is that over here, the set timeout is going to say, okay, I need to wait some amount of time. And once that time passes, or at least that time passes, in our case 3 seconds, then it's going to not just execute the inner function, which in this case is a console log. It's not just going to execute that inner function. It's actually going to hand it. It's going to pass it, indirectly back to the call stack via this callback queue. So set timeout gets put on here on the call stack like normal. JavaScript says, hey, that's not for me. That's for the Node API or the web API. The Node API in this case handles it, waits 3 seconds, and then once the 3 seconds is over, it passes off the inner function, the callback function, to the callback queue. And then once something is in the callback queue, let's say this is the only thing there, or it moves to the front of the line, it now has to wait for the call stack to be cleared in order to get put on the call stack. And so there's this event loop, which is basically just, you can think of it like a while loop, like an infinite while loop that's just spinning. It's constantly checking to see, is there anything on the callback queue? And is the call stack empty? So if there's something on the callback queue and the call stack is empty, then this function will get put on the call stack, and then it can be executed finally. So, you know, it's a little bit complicated, and you don't really need to, you know, be an expert or anything like that. But that's how it works. So that's why something like this can work, and I can execute this, and then execute this, and execute this, and my program is done. So I haven't like frozen. Whereas this Python, because it's all synchronous, it's all happening, you know, in a single thread. Does this, then does this. This is blocking. So this sleep is blocking. It means my program is, I can't do anything else in my program. It's just sitting there and it's frozen, basically. It's waiting for the next thing. Whereas the JavaScript program, the main thread is clear. So I execute this, it gets passed off, I execute this, and then I'm done. Right? So, and that's really important in a user interface, because that means that if this were blocking, if I were actually literally like wait 3 seconds right here, then I wouldn't be able to do anything else. I wouldn't be able to scroll on the web page. I wouldn't be able to click buttons. I wouldn't be able to do anything. So you don't want to lock the interface while you're waiting for stuff. So that's why it's structured this way. So set timeout is actually, you know, I don't really care about set timeout that much. It's definitely, you know, it can come in handy and you can definitely use it. But what I really want to talk about is promises. And promises kind of work the same way. So a promise is basically something that you do in your code that's going to return a non-immediate result. So if I want to execute console log, it's just, you know, I put it on the call stack, execute it, and it's done. I get the result, right? Basically, everything we've done so far has been synchronous, where I write a function that adds 2 numbers. Those 2 numbers get calculated. I get the return value, and then I can do something with the return value. Here, when you use a promise, it's almost always, for our purposes, it's basically just going to be an API call. It can be other things like reading a file or doing other things, but it's basically a side effect that's going to potentially take a while. It could be, you know, it could be effectively immediate. It could also be, you know, it could take 5 seconds or 10 seconds or whatever. And promises allow you to kind of make that call. So I can say, I want to get, you know, some JSON from my server. So I make a request to the server, and then I can keep going. The rest of my code can keep executing. So it doesn't freeze. I don't have to freeze and wait for that result to come back. And then once that result does come back, then I can do something with it. So I'll put something on here, which is a promise. Hey, make a request to the server. That gets put over here, basically, as a promise. And once that promise resolves, once, you know, response comes back from the server, then I can say, oh, okay, now I'm gonna use that. Basically, gonna like continue with that promise and use it. The the syntax is a little weird, and conceptually it's different. So if this, if this strikes you as being kind of counterintuitive or weird, that's perfectly normal. Okay, so let's take a look at a promise. So I'm gonna start by just creating an actual promise. In practice, you're not going to be making your own promises. You're going to be consuming them. So you'll use some other third-party library, and you use some function to get something, and that will return a promise, and then you'll have to deal with the promise. But here I'll show you how to create one, just so you can kind of see how it works. So promise, I can create one. There's a couple different ways you can do it, but I can create a new promise. So this is a class, and I'm creating an instance of this promise class. And the constructor, the parameters that a promise will take is a function. So this takes a function, just like we've seen so many times in JavaScript. So the constructor takes a function, and this function actually has two parameters. So it has two parameters, and both of these parameters, we can call them A and B for a second. These two parameters are actually both functions themselves. So we're getting into, function calls a function, returns a function. So it's a little confusing, but so promise takes a function, and both parameters of this function are themselves functions. And these are conventionally called resolve and reject. So as you might guess, resolve is the happy path, and reject is the sad path. So resolve is when everything works out, and reject is when there's a problem. So what you do is inside of this function right here, you'll do whatever logic you want to do, like make a request somewhere, or do anything else. And then once you get a result back, you can, if it's the result that you want, or there's no errors or anything, you call resolve, and you pass it whatever that value is. So let's just do something like let we'll do if Okay, so this is kind of a stand-in for whatever application logic we're doing. And whenever we do ultimately get something, if it's what we want, then we say, okay, good, and we call it resolve. And if it's bad, then we call it reject. So I'm going to go ahead and console log my promise. And if I run this, I see that I have this promise object. So it's a promise object, and in this case, it has a good value. If I do false, it's a little more complicated, but you can see that the state is rejected here. So promises can basically have three different states. There's a pending state. So that's when it's basically waiting for whatever you want to happen. And then if it's, if it's resolved, then it's, forget the term, but there's basically, it's either rejected, which is this case, something bad happened, or it's resolved. In either case, whether it's resolved or rejected, it's settled. So it's, it's done doing its thing. Okay, so you'll see this error message or something like it. It's basically saying that this reject is throwing an error, basically, and I'm not handling that error. So we'll look at how you handle that in a second, but for now, this is the promise object. Now the question is, I want to get at this value, right? So the whole point of this promise was to get this thing. So here's the value that I want. So I want to, make a request, get back a response, and if that, if that process went smoothly, I get that response, and then I use it in the rest of my code, right? The problem is that promises don't really work that way. You can't really combine synchronous code and asynchronous code. I can't. It just doesn't work. It's unfortunate, but it just doesn't work. So you can think of whenever you're using async code or promises in JavaScript, even though it's all written in the same file, you should think of it as basically being like happening in another dimension. You can imagine, that's like a three-dimensional view, but this is no longer really a part of your code. Like this value, you can't get at it in the rest of your normal synchronous code here. What you have to do is once it's in a promise, it's got to stay in that promise. So what you do to access those values and further manipulate them is my promise dot then. So there's a method, another method on this promise instance, this object, and then you can do stuff here. So then also takes a callback, surprisingly. So I'm going to call this result. And if I run this, I'm going to make this good for now. Then I have access here to the actual value. Now I still can't do something if I do let result equal actually let me change this. Okay, so if I run this, notice that this outer result is undefined. And also notice the order in which these get logged. So this gets logged, and then there's some other stuff happening off of the main thread here, and then this gets logged, and then after that, this gets logged. So even though this is, I'm not really like waiting for anything, this is effectively happening instantaneously. It's still not exactly instantaneous because it has to go through this extra step. And so while my promise is kind of making its way around here, the other console log is being executed on the call stack. So the point of showing you this is to show that that's kind of how it's structured, and that you can't, you're gonna want to do this. Your instincts, because of your experience with synchronous programming, is going to be, okay, I get the value, I reassign it to something else, and then I can use it. But it just doesn't work that way. It's maddening, but it just doesn't work that way. So this is happening in another dimension. This is, this is out of contact from the rest of your synchronous code here. So what can you do with it? Well, you can do stuff like modify the DOM. So that's kind of what this stuff is good for. If I'm trying to, calculate a value, grab something asynchronously, and then use it in the rest of my synchronous code to calculate a value, it doesn't work that way. Once it's in a promise, it has to stay in the promise. You can't like return something from a promise. Now there is so promises have syntactic sugar. So they have a nice API, which is called the async await. So you can use async await, so you can write what look like normal functions, but under the hood, they're actually promises. So that's kind of what a promise is and how it works. And so now I'm going to let's do a slightly different example. So how we're actually going to be using this 99% of the time is making an API request. And there are, just like Python has the third-party requests library, which is basically this, the standard way of making HTTP requests. Built into the browser is also something called fetch, the fetch API. And there are lots of third-party JavaScript libraries that will handle this, but we're just going to use fetch for now. So if I go to tab here, so I'm going to call fetch, and then you can make like, a normal network request here. So HTTP : / and I'm going to use the JSON because, well, first let me do something else. Okay, so I did this. So there's a lot of things going on here. One, there's some errors, and two, for now, let's look at this. So this is a promise. So this is a rejected promise. So fetch, even though it looks like just a normal method, is actually returning a promise. So fetch returns a promise, and in this case, the promise was rejected. So I made the request, but it was rejected. So now the error here is not directly related to promises. This is something that we'll see later. But this is basically something called a CORS error. So your browser won't allow you to make what's called a cross-origin request. So I'm here on my browser and I'm trying to make a request to a different server. And so that other server can basically say, you're not allowed to do that. So we're not going to worry about that right now, but that's an error that you will definitely encounter. So just be aware of it. And to get around this, one thing I can do is JSON. I'm going to copy this. So this server is more forgiving. I don't know if I can do that. Yeah. So fetch. Okay. So I'm going to get the same error here in the browser, but if I run this, I can run this here. Let me create an HTML page real quick. So index.html. The usual boilerplate. I'm going to add script. And the source is going to be ex.js. So, and then my ex.js, I'm going to make that fetch request. Whoops. Oops. And I'll make this a string. Okay. So now I should be able to, I'm going to console.log x. And then I'm going to run this using live server. And if I open the browser, I can see that I have this promise thing. So I didn't get that error. So this works. So there's, it's kind of a pain. There's just, basically safety restrictions that the browser has, and then other servers can forbid. I'll show you the header real quick so you can kind of have an idea as to what's happening. Go into the network request. I'm going to refresh this. It makes the request. And I can see that request right here to users. So I made a GET request to JSON placeholder, blah, blah, blah. And the response headers. So this is the cores related. So access, control, allow, origin. Here it's showing my local host and the port number that I'm running on. But it's basically getting this dynamically. So certain servers will allow you to make a request like that. Like, so typically, like if I'm Facebook or whatever, and I'm serving you up the Facebook page, so I give you a bunch of HTML and so on that gets rendered in your browser, and then from there I make a request to the Facebook server for more information or something. That's fine. Facebook, Facebook wants you to be allowed to do that. But what Facebook doesn't want is for, MySpace, you go to MySpace, and then from MySpace, they're like, hey, go get some stuff from Facebook. So that's called a cross-origin request. And so by default, most servers just won't allow you to do that, and they can control that with this header, and then browsers will also just prevent you from doing it as well. Okay. All right, so we go here, we can see that this is an actual promise, and we can see that it's fulfilled. So it looks like everything worked, but when we try to like console log this, I don't want just, a promise. I want this JSON. Let me get one user just for the. Okay. So I refresh this, and so now I'm just going to get one user. Still can't really do anything with it. And so what I have to do is I'm going to say response here. Again, I can't really access this asynchronous promise with synchronous code, like a console log out here. So I'm going to have to stay within this promise. So response dot then, so I can use the dot then. And then dot then will take a callback function. So I'll just call this value. And then I'm going to console.log the value here. And if I run this again, now I get something a little different. It's still not exactly something that I can use, but I can see that there's body, there's headers, there's status. So the way that the fetch API works is there's kind of a two. This is just particular to the fetch API. So the first, so I make the request and I get a promise back. If I want to like unwrap that promise and grab the value that it returns, I call .then. But with the fetch API, this first round, basically, this first time you access it, you're actually you're just getting the headers, basically. So you get some information like, status and so on. So you can check, was the request successful? If so, do this. If not, do this. But you're not getting the actual like content yet. So you have to do another .then, and I'll put these on new lines. You can do that with syntax. So .then. So instead of just console logging it, I'm going to basically process it. So value.json. So this is something that's available to you. This is just how you do it with a fetch API. So I'm going to convert this to JSON because that's what I want. Okay, and then from there I can do, and then so I should be able to actually get the JSON that I'm expecting. So there's the JSON. So now I can just grab the name, for example, because this is the JSON object, and I get the name right there. And then what you might do, instead of just console logging it, you might want to do some DOM manipulation. So let body equal document dot query selector body, and then I'll create like an h1 tag. Let h1 equal document dot create elements h1 dot inner text will be value dot name, and then I'll append it. So body dot append child h1. And so it happens basically instantly, but if I refresh this, let me try. It's going to happen instantaneously, but yeah. So that's the idea. So if I wanted in the rest of my code to say, let's say grab this and then, make it all caps or something, and the rest of my synchronous code here, I can't do that. So if I want to keep processing this or keep doing stuff with it, I have to use something that, creates a promise and consumes a promise. Are there any questions about that?
So because you took the data from the JSON and moved it to the DOM or to your HTML document, you can now use it again since even though it was a promise.
So you could potentially do that, but the problem is the problem is that value might not exist. So you could, you could do something like grab a value from the HTML DOM in another function. You could definitely do that, but you just have to make sure that it exists, and it would be difficult to do that unless you kind of triggered it. You either triggered it inside of another promise, or you like had another button that the user clicked. Like, for example, okay. So first off, before I get into that, let me just I'll handle that in 1 second. So let me show you what happens if there's a failure, for example. If I save this, there's a 404 here, and then I get undefined, which is not what I want. So what I can do is add a catch. So this is if something goes wrong here. It can do, so there's an error. And I'll just do the same thing, but I'll append blank. So I would have to throw another error in here actually. So I would check here if there's the correct value, and then if not, I would have to throw another error. I could also do that here. So if value, you just do if not value, raise. Is it raise exception or throw? Throw. Throw error. Sorry, I forget. JavaScript versus. Let's just do error. And it should get handled there. Might have to call the create a separate reject function here. Let's see. And so one function. It's also tricky because this is not strictly like not everything that you think would be an error for fetch is actually an error. Anyway, so yeah, I'll take a look at that later. I don't want to waste time here, but I think I'd have to check that the, let's say, the status code. If the status code is, you know, not 200, then throw an error or something, and then it should propagate down into the catch. But yeah, to answer your other question, can you do something like this? So you could have, let's create another element here. Just do, keep it simple here. H2. And then here, we'll do query selector. And then H2 dot add event listener. On click. And we'll do something here. And I could do H1 equals documents dot query selector H1. There's only one of them, so that's fine. And then H1 H1 dot. I think I could do and we'll check that out, and then console. Let's see. Yeah. Null added on this there. Yeah, so let me not do this. So I think, let me see if this is. Let's see. So query selector for H2. Did I, so I did create that. I
So we
created
don't have to have a button for an on click. I was trying to do something like that the other day.
No, you can click you can click anywhere.
Anything that has like basically on click that makes it clickable. Is that the way it works?
Yeah, yeah. So buttons will also have there's a submit event, which is slightly different, and there's some default behavior that comes with the submit event. But basically, yeah, a click works fine. Let me see. So it doesn't like. Let me just try console logging. Null. Why is that null? Interesting. Try refreshing this.
Do you have to console log the text content? Oh, you're trying to get the header?
Yeah, so
The tag, yeah.
for now, eventually, yeah, but for now, I'm just. It's weird that I can't H2. Is there something wrong with this? Let me try a P tag here. ID equals P. And then in the JavaScript. I'm confused. There's obviously something stupid that I'm doing, but I'm not sure what it is right now. Does anyone see anything obvious here? Let me comment that out for now. Why is that null? This is the right example, but let me just try putting this here in the browser. Let's see. H2 has already been declared. Sorry about this. You have to watch me debug. #2 is not a valid selector, so not #2, but #P. So I can grab that here. P dot text. So I can get that here. I'm not sure. Let me just try maybe restarting this live server. Maybe there's something got wonky. Okay. Well, I don't know what's going on there. I can take a look at it. I'm confused. This looks obviously correct to me. And I just did it in the browser and it worked. I don't know. But to answer your question, you could do something like that. So I make an asynchronous request and it modifies something on the DOM. I should be able to then grab it, but you just have to make sure that basically it exists. You're not trying to access it before. So you'd have to control that, either making it dependent, like within the promise, you can chain things together, or just make it depend on an external event like that. Okay. Are there any other questions? Sorry, but this is maddening. I don't know.
Is it that async? Is it like that defer thing with the script in your HTML?
Oh yeah, maybe that's it. Thank you. Thank you very much. So that is the exact that's an illustration of the problem. So the issue is that I didn't do async. So it tried to run the script because the browser loads everything in order, just like JavaScript is executed. So from top down, it loads the script, and in my script I say, hey, grab me, this h2 tag, but the rest of this hasn't been loaded yet. So it's trying to access an element that doesn't exist, which is why I was getting the null. And so you could solve that problem by either putting the script tag at the end of the body when everything else is loaded, everything that it references, or you can use the defer. So thank you very much, Kasim. So yeah, to go back here. So H1. So that works now. Cool. So now we'll go here. So now this is, I think, the P tag. Actually, that is still H1. And that is P. Okay. So now that should work. Let's see. So now if I click here, this should show up. But even though this information, I obtained it asynchronously, it now exists here and I can kind of see it. But if I try to create a reference to the inner text initially, so if I did something like in my global scope, yeah, I'll just do it here. In my global scope, if I did like this, I believe that this is, if I were to, let's see, well, we'll see. I think that this reference is going to be stuck at what it is initially. It should be undefined. Yeah. So even though this is now loaded, this is still going to tell me that it's undefined. So H1 doesn't, I think it doesn't have an inner text initially, because I'm creating it asynchronously. But even if I created the H1 tag here and then populated the inner text, I think I would still have the same issue. So even though it looks basically instantaneous, so yeah, there are just some gotchas with asynchronous programming. Let me try doing this and then I click this. Yeah. So another variation is that I just grab a reference to the H1 and then delay accessing the inner text until it should exist, but still have that issue. Okay. All right, I'll stop here.